The solubility table for ionic compounds is a very important skill in correctly writing down chemical equations that require you to fully use all the states. So picture the scenario. You have a beaker that contains an ionic compound that's a salt. Take, for example, you have the very common compound NaCl, and that's a solid, basic table salt, minus the iodine. And you take that table salt and you put that into a beaker that contains water. Like any ionic compound, you have to make a decision based on some sort of a solubility table, like this one. Will that compound that you put into that solution dissolve? And if it does dissolve, it will become aqueous. Or will it not dissolve and remain a solid and have low solubility? So this table essentially is divided into two sections: high solubility and low solubility. I'll separate those with a line. To read this table, you need to find the anion from your compound in question and find the column that contains your anion. So chlorine in the form of chloride is located in the very first column. The way this table works and how it reads is that most compounds containing chloride have high solubility, meaning they will be aqueous or invisible in solution. Put an ionic compound containing chloride, in this case say sodium, into water, it breaks apart and you cannot see the particles, they dissolve. If you had chosen to put into a solution, for example, silver chloride, that would be a different outcome, because silver chloride, as you can see in the table, is one of the 5 ions listed here that when combined with the chloride has low solubility. So you need to pay attention to how this table gives the information. And on the top half, an ion, cation with the anion in question will produce high solubility or be soluble. If it's in the lower half, it's going to be low solubility, what we call a precipitate or insoluble. So silver chloride would not dissolve, but sodium chloride will dissolve. So when that goes in, it becomes NaCl, AQ or aqueous, as in you cannot see it. It breaks apart and fills the whole container and becomes a homogeneous mixture. The concentration is the same throughout. Let's take another example. Say you're working with another common compound. Say you had calcium sulfate, CaSO4. Now that's a solid, like all ionic compounds are. When you put that calcium sulfate into water, the question you want the table to answer is, will that calcium sulfate dissolve or will it stay a solid? Well, the table reads, based on the anion of sulfate here, that most sulfate ions are highly soluble, except that there are 6 ones to watch out for. And look at that, calcium is an exception. So the calcium sulfate, when it goes into water, it will not dissolve. So it will remain a solid. Now, there's a couple tricks to this table that could save you a lot of grief and actually a lot of time. And it all comes down to you following this important sentence at the bottom. And this sentence says, all group 1 compounds, including acids, and all ammonium compounds are assumed to have high solubility. Let's translate what that really means. So a group 1 compound, for example, go to your periodic table. Group 1 is going to include your lithium, your sodium, your potassium, your cesium, and what's the other one I can't think of right now? There's one more, can't think of it for the life of me. Any of those ions with any compound, no matter it be a nitrate or an acetate or a sulfite or a phosphate or a carbonate or a sulfate, hydroxide, etc., sulfide, it'll always be soluble. You never have to look it up. Any group 1 compound, no matter what it's with, will always dissolve in a water environment. Any ammonium compound, so ammonium is an NH4. If you put an ammonium compound, ammonium ion with any anion, anything at all, be it a nitrate, acetate, any of these ones on the table, or anything else you can think of together, something weird like, say, ammonium borate, BO3 with a 3 negative charge, and you crisscross all that, and you get NH43, BO3, ammonium borate, and you're asked to decide if this compound will dissolve or not dissolve. The first question that I would usually get is, how would I know? Borate is not listed as an option. And you're right, borate is not on the table. But what is on the table is this clue that an ammonium ion with anything will always be soluble. So if your question is, will that dissolve in a water environment? The answer is certainly yes, because all ammonium compounds are going to be aqueous. And the last tip that I can give you that'll help you save a lot of time is this last column that says all nitrates are soluble. So don't ever letting to look it up, no matter what you could possibly think of. Put it together with a nitrate. So say something like a lead. Will lead-2 nitrate be soluble in water? And the answer is yes, it will, because all nitrates are soluble in water. What about some kind of a silver atom? Silver's a 1+. Silver in a nitrate, it will certainly dissolve in a water environment. So all nitrates are soluble. All group 1s are soluble. All acids are soluble. And all ammoniums are soluble. And that's going to save you a heck of a lot of the time when you get down to doing an equation that requires you to do a double replacement and pick which compound is going to be the precipitate. Remember, all group 1s, all ammoniums, and all nitrates are soluble. Consider this reaction. If you had a solution of sodium hydroxide, which is aqueous by definition of a solution, and you were to react that with an iron, say an iron 3 chloride solution, AQ. Your first job would be to complete the reaction and then predict the states of the products. So hopefully you would look at this and you would see we have a cation and a cation and an anion and an anion. We're going to do a double replacement. On the product side, we're going to get sodium with the chlorine, Na1+, Cl1-. The state we'll identify in a minute. And you're going to get the iron with the hydroxide. Now the iron charge had to have been a 3+. If the subscript down here was a 3, therefore it doesn't change. You're going to get iron 3 hydroxide. So since hydroxide is a 1-, you'd have to crisscross. and do it FeOH taken 3 times. So what I want to know is that when the sodium and the chloride ions collide together in solution, are these 2 ions going to stick together and make a mass called a precipitate, or are they going to bounce apart and remain soluble? Well, as you know, salt is soluble. And this table says most chlorides are soluble. This is silver chloride or a lead 2 chloride or copper 1 chloride or thallium chloride or mercury 1 chloride. So this is going to be aqueous. Now the hydroxide iron, this column states that a group 1 metal, so like the lithium or your potassium or your sodium, they would all be soluble. The ammoniums, of course, would be soluble, and so would a strontium hydroxide and a barium hydroxide. Everything else will be down here, what we consider low solubility or a precipitate. That'll be a solid. And this compound, when the iron ions and the hydroxide ions collide together in that solution, they will stick. They will form a mass. In this beaker, you would get a whole bunch of solid, which would eventually form a lump on the bottom of your beaker because they are insoluble or a solid. So, in summary, for a compound in question, find it on your table. So you're going to be able to decide for all carbonates, phosphates, sulfites, acetates, nitrates, sulfates, hydroxides, sulfides, and your chlorides, bromides, and iodides. If you're asked to decide the solubility of a compound where the anion is not listed, remember the tricks. All group 1s are soluble. All ammoniums are soluble. All nitrates are soluble. So say I gave you a weird compound again, something like potassium dichromate, K2Cr2O7, and I want to know if that will dissolve. Your first instinct might be to say, well, how could I tell? Because the dichromate ion is not listed here. And you're right, but potassium, being a group 1 ion, put together with any other ion will always be soluble. So that would be aqueous, which means it will be soluble, which means you won't see it in the solution. It will completely be dissolved like Kool-Aid in a glass of water. So solubility of ionic compounds. Use a table like this. Remember hints about group 1, ammonium, and nitrates, and you should have no trouble to do a question.